Hi guys. So today we are going to look at graphing some transformations to our sine and cosine functions. So the transformations are going to be similar to what you have done before. If you were not in class, you'll probably want to look at that Desmos activity first, because that will help you see these a little bit more visually. It might make it a little bit easier for you. So what we're going to do is we're going to look at transformations for both sine and cosine. These are going to be almost identical. The only one that's going to be different really between sine and cosine is this C value here. And we'll talk about that in a second. So the first thing we're going to look at is A. Okay, A is the number that's multiplied out in front of either sine or cosine. A stands for the amplitude of the graph. So amplitude is the distance from the middle height to the top height. So for example, if you have your sine graph like this, or cosine graph, whichever one it is, okay, your distance between the middle and the top, that distance is the amplitude. If there's a negative out in front, now that doesn't really affect, you're not going to have a negative amplitude, but if you have a negative out in front of your sine or your cosine or out in front of your amplitude, that is going to be a reflection. So your graph is reflected over the x-axis. The B value is what you have that's written right here that comes right after sine or cosine. Now you'll notice it's factored out. So for example, it's sine parentheses 2 then parentheses. Okay, so it'll always be written that way. That B value is used to find the period. Now this is not actually a number that's going to be on our graph. We use it to find the period. The way we find it, 2 pi divided by B is how we find the period. Or you can go backwards and you can do 2 pi divided by the period to get B, either way. C is going to be what's called the phase shift. Now, if you remember when we looked at these, kind of the pictures of them, this one's interesting because it can be a lot of different things. That's why we don't really call it a horizontal shift, because it's possible to have more than one correct phase shift and still get the same equation. So what we're looking for here is a specific type of point, and this is where it matters if it's sine or cosine. A, B, and D are all going to be the same regardless if your graph is sine or cosine. C is different though. So if we're talking about a sine graph, okay, this is going to be a middle point, but not just any middle point. It's a middle point before the graph moves up. Because if you think about your sine graph, it looks something like this. So there's a middle point here, and there's a middle point here. The one that we'd be looking for is that green point, because on that green point, it's middle, but then your graph goes up. Whereas on that blue one, it's middle, and then your graph goes down. That's what we would do if it was reflected, all right? So for normal sine, we're going to use that green point, which is the middle one before our graph goes up. If we're talking about cosine, it's a high point, because cosine starts at the top. If the graph is reflected, is what we just said, then sine is a middle point before the graph moves down. So that's how it would be reflected. And if cosine were reflected, it would be a low point. The last one is D, that plus that's over there at the end. That D value is going to be your vertical shift. Okay, the vertical shift is going to be the same as the middle Y value. And a lot of these details are going to be really important when we actually draw the graphs next class. For today, we're just going to identify what these transformations are, and we're going to find them on the actual graph. So to start, we're just going to identify them on the equation. So the first thing we're going to find is the amplitude. The amplitude is a number that's out in front. So the amplitude here is 3. Right? The vertical shift, that's what we're adding to this equation. In this case, I'm adding 2. My vertical shift is 2. The B value is whatever number is listed there. In this case, I don't see a number, so that number is 1, because 1 times anything is still anything. The period is 2 pi divided by B. So this is 2 pi divided by 1, so the period is 2 pi. The phase shift is what we've added or subtracted, so we've gone right, pi over 2. And then because this is a cosine graph, that phase shift is going to be a high point. All right, let's do the next one. Amplitude is 7. Vertical shift is whatever you add or subtract. We have not added or subtracted anything, so our vertical shift is 0. The b value, that's the 2. That's in the parentheses there. So the period is 2 pi divided by 2, which is just pi. The phase shift is pi over 4. And because this is a sine graph, then this is a middle point, and it's a middle point, and then your graph will go up after. So it's middle, then up. All right, let's look at the next one. Amplitude, number out in front. In this case, there is no number in front. So it's 1 because 1 times anything is 1. So if the number's missing and it's multiplied, it's 1. If the number's missing and it's added, it's 0. Think about what number would not change that equation. Vertical shift is -5. The b value, what's in front of the x, what's touching the x, that's pi over 2. So your period is 2 pi divided by pi over 2. When we divide fractions, we flip and multiply. So that's 2 pi over 1 times 2 over pi. So my period is 4. The phase shift, there is nothing added or subtracted inside the parentheses, so that's 0. This is a sine graph, so it's a middle point, and then your graph goes up. All right, next one, cosine. No, there is a negative out in front. Now remember that negative doesn't really change the amplitude. The amplitude is still 3. The height from the middle to the top is still going to be 3. Vertical shift, how much we're going up? We're going up 3. B value is 2. Period is 2 pi divided by 2, so the period is pi. Phase shift is negative pi over 2. And then because this is a cosine graph, normally it's a high point. Now this is where the negative matters, since it's been reflected. So it's a cosine graph that's been reflected, it's going to be a low point. All right, the last one you'll notice has a little bit of a difference. All the other ones we've looked at so far, that b value has been factored out like this, to where there's a parenthesis following it before that x plus or minus. We have to rewrite this one so it looks like that. So I'm going to take that 2, and if I do pi over 2 divided by 2, then I have pi over 4. So now the amplitude, there's nothing there, so it's 1. Vertical shift, there's nothing there, so it's 0. Because remember, adding 0 doesn't change, multiplying by 1 doesn't change. If the amplitude was 0, this graph wouldn't exist. All right? If the vertical shift was 1, it actually would go up 1. The b value is 2, so the period is 2 pi divided by 2. And then the phase shift, this is why we need to factor it out. Our phase shift is going to be a negative pi over 4. And now this is a sine and it's negative. So if it's negative sine, it's still a middle point, but because it's reflected, it's going to go down after the middle. All right, so now we're going to do the same thing, just opposite. Okay, we're going to write an equation that has these features. So it says sine or cosine. It does not matter which one you do. It says it has an amplitude of 5. So 5 goes out in front. I'll write this one as sine. The period is 4 pi. So the 4 pi is actually not going to go in my equation. B is going to go in my equation. B is 2 pi divided by the period. And 2 pi divided by 4 pi is 1/2. So 1/2 goes in my equation. Phase shift, so it's x minus pi over 2. And then vertical shift, down 7 is -7. All right, next one. Again, I'll just do sine again. Reflection over the x means I'm going to have a negative out in front. It does not say anything about the amplitude, so I'm going to assume the amplitude is 1. The period is 8, so the b value is 2 pi divided by 8, which is pi over 4. The phase shift is 1, so x minus 1, and then the vertical shift is plus 3. All right, last one. If you feel comfortable, pause the video, try this one on your own. So I'll do cosine this time just to make it different. It really does not matter. I'll do amplitude's 3, cosine. The b value is 2 pi divided by pi over 2. So 2 pi over 1 times 2 over pi. So the b value is 4. There's no phase shift. So if you want to say x plus 0 or x minus 0, you can, but you don't need to. So I'm just going to write x. It's not wrong if you say x minus 0 or x plus 0. That's fine. It's still the same equation. And then the vertical shift is up 1, so plus 1. All right, so the last thing we're going to do is really just a combination of these two things. So we're going to write the equation, but instead of writing it from the information, we're going to look at the graph and determine that information. So we're still going to follow the same format. F of x equals a sine or cosine b x minus c plus d. So let's start with a and d. Those are usually the easiest things for most people to find. Okay, d is the vertical shift. The vertical shift is the middle y value. Well, let's find the middle of this graph. Okay, 3 is the middle of this graph. So my d value, my vertical shift, is 3. All right, let's find our amplitude. So our amplitude is the distance, the height, from the middle to the top. So that height right there, that's going to be my a value. That's my amplitude. That height is 2. All right, now let's find the period. Okay, so my b value is going to be derived from the period. The period is how long it takes this graph to repeat. So you can find this a lot of different ways, but basically find a point on the graph and then find where that graph fully repeats itself. So I'm going to go from here to here. Now you didn't have to pick those. You could have gone from this point to this point. Either of those would work. You also could have gone from maybe this point to this point. Or you could have gone from this point to this point, wherever you need to go to see a full cycle of that graph. But usually it's easiest to see kind of the high point to the high point or the low point to the low point. So we're going to see how much distance there is in between that area. So that total distance, there's two ways you could do this. You can take the further point and subtract the first point. So that becomes 4 pi over 2, which is 2 pi. Or what you can do is, if you think about it, this distance right there, that total distance is pi over 2. This total distance is 3 pi over 2. If I add those distances together, I have 4 pi over 2, which is 2 pi. So however you decide to do it, that total distance right there, the period, how long it takes to repeat, is 2 pi. So now we need to find the b value. Okay, so the b value, what actually goes in our equation, is 2 pi divided by the period, which is 1. All right, and then the last thing we need to find is the c value. Now this is probably the hardest one because there are a lot of actual correct answers. It also depends if we're doing sine or cosine. Up until this point, all of these things are the same, whether this is a sine or a cosine graph. So I'm going to go ahead and write what I have as both sine and cosine. So f of x equals a, we'll do sine, b is just 1, so since it's just 1, I won't write it. I'm going to leave this blank for a second, plus d. Then I'm also going to write cosine. Right, so that now at this point, the last thing we need, it depends which one we're going to do. So this is where we look for the type of point it should be. So if we're talking about a sine graph, the phase shift for a sine graph is a middle point. But again, it's not just any middle point, it's a middle point before your graph moves up. So one of those points could be this point right here. That's a middle point before your graph goes up. The x-coordinate of that point is negative pi. So I could write plus pi. But again, that's not the only right answer. Over here at pi, that's also a middle point before your graph goes up. So another correct answer here is x minus pi. That also works. Now let's look at cosine. So for cosine, we need to have a high point. Cosine starts with a high point. So find that top point, find your x value. So that's one possible answer. This is another possible answer. So we also could have done x minus 3 pi over 2. Any of those are correct. Now, there's actually even more possible answers in this as well if you consider negatives. Now, you don't have to write it negative, but if you wanted to, you could have. All right, let's try a couple more of these. So let's start again. I'll write our base equation now. A sine b x minus c plus d. All right, let's start with d. Let's start with that middle y value. Well, that's my middle y value right here. -2 is my middle. Let me use a highlighter. So d is -2. Amplitude, middle to top. That total distance is 1. That's my a value. That's my amplitude. All right, let's find the period. So how long it takes this graph to repeat. So I could go from this point to this point and find that total distance. So that total distance from -pi/2 to pi over 2, that total distance is 1 pi. So again, I can either say that this is pi over 2 plus pi over 2, or I could say the later value minus the first value. And I end up with a distance of pi. So the period is pi. So the b value is 2 pi divided by pi. So the b value is 2. So now I'll go ahead and fill in what I know on my equation. So a is 1, so I don't really need to write it. I'll do sine b x. I'll leave a blank because we'll figure this out in a second. And then I'll do -2 because that is my d value. So now let's figure out what that phase shift needs to be if this is a sine graph. So sine, we're looking for the middle point before your graph moves up. So that would be like this point right here, or this point right here. Oops. Either of those x values could be used for our sine graph. So I could do x plus 3 pi over 4, or I could do x minus pi over 4. Either one would be correct. All right, now let's write a cosine graph. So it's still going to be cosine 2. We'll leave a blank. Cosine's going to look for the top point, the high point. So the high point for cosine is right here at -pi/2, or right there at pi/2. So you can just pick either one. I'll do x minus pi/2. So again, these have more than one correct answer when it comes to that d value. But you'll notice both of them have the same a, b, and d. It's just that c that changes if it's sine or cosine. All right, we got 2 more. So again, let's start with our middle y value. If you feel comfortable, pause the video, try this one on your own. Okay, middle y value is 1. So that's your vertical shift. Amplitude is 2. Okay, amplitude is 2. Your period is a little easier on this one because there's no pi's. It's kind of hard to see, but that point right there is 1. That point right there is 13. So the total distance there is 12. So our period is 12. So our b value is 2 pi divided by 12, which is pi over 6. So let's fill in what we know. So we're going to have 2 sine pi over 6. We'll leave this for a second. And then I've got a +1. And I'll also write it as cosine. All right, and then let's find that phase shift. So sine, looking for the middle. All right, so for sine, our phase shift, we are looking for a middle point before our graph moves up. So for sine, we could use this point, or we could use that point. So I'll just go ahead and say +2. Again, if you had used x minus 10, that also would work. For cosine, we are looking for a high point on our graph. So I could use this one which is 1, or this one at 13. And I'll just use 1 because it's closer. And that's my graph. All right, last one. This one's a little tricky because we don't see the whole graph, but we see enough to be able to get this figured out. So again, let's start with our vertical shift. So our middle point here. So that middle is at 1. So my D value is 1. A, the amplitude. Okay, that height is 3. B, 2 pi divided by the period. Well, the period here, it's hard to see because you don't see the whole graph repeating. But we do see half the graph. So if from -1 to 2, that's a distance of 1, 2, 3. If it takes 3 to get half the graph, it's going to take 6 for the whole graph. So that's our B value. Our C value, our phase shift. Okay, again, it depends if it's sine or cosine. So if it's sine, middle before the graph moves up. That would be this point right here, which is at 1/2. If it's cosine, we're looking for a high point, which is at 2. So 3 sine pi over 3 x minus 1/2 plus 1, or 3 cosine pi over 3 x minus 2 plus 1. Again, the only numbers that are different between sine and cosine are those two right there. All right, so that is it for transformations. We'll have our quiz first, but after that we will start to actually draw these graphs and use what we learned today.